hope anyway. An equation for the hyperbola with the given characteristics. So the vertices are -3, -6. So 1, 2, 3, 1, 2, 3, 4, 5, 6 here. Whoop, oh, that was weird. Let's try that again. 1, 2, 3, 1, 2, 3, 4, 5, 6. And -3, 2. -3 up 2 right here. So from those 2 points, we can get the center. And if it was some weird decimal values, you could, now the -3s are going to be the same because it's lined up on that vertical line, but then 2 minus -6, you really should take the opposite value of that because it could be negative, but the distance between the two is 8. So up or down 4 from each. 1, 2, 3, 4, so right there. Now, of course, with the numbers being that small, you can just count it out and find where the middle is. But that gives us the center is -3, -2. It also tells us that this hyperbola would open up and down, or it's a vertical hyperbola, which means the y would be positive, or what we say is first. So we need to fill in this template. I think this is a nice process to go through. Fill in the template with the values that we need. Well, we know the center, so keep y with y and x with x. So this needs to be a +2, and this needs to be a +3. I always write minus because you can always easily change it to a plus if you have to. Not only that, I know that A, the distance from the center to the vertex, A must be 1, 4, right? A must be 4, so that puts us 16 first. Well, and it's also under the y because we're going up and down. Well, now I need some more information to find b squared, because that's really what we need. We need b squared here now. But they tell us that the focal points are at -3, -7, and -3, 3. And I only needed one of those to be able to find out that the b is equal to 5, so that puts a 25 under there. Oh, that's completely wrong, by the way. That's not B, that's C. I totally messed that up. I couldn't have messed that up more if I had tried. Not B. I'm glad I caught that, obviously. This is C. My apologies. C is 5. But A squared plus B squared is equal to C squared. We know that A squared is 16 plus B squared equals 25. 5 squared. So b squared is equal to 9. Now, no use square rooting it, because we'll have to square 9 there, not 25. That was a silly mistake. Any questions? All right, hopefully I didn't mess you up on that. Center to focus is C, not B. All right, let's move on then. An equation for hyperbola given characteristics. Vertices -3, 0. -3, 0, and -9, 0. 4, 5, 6, 7, 8, 9. -9, 0. So that tells me the vertices. Well, let's get the center. We can just count this time. We don't have to subtract. 1, 2, 3, 4, 5, 6 units. So 3 units from each is the center. So -6, 0. But I also know now that this hyperbola is horizontal. It opens right and left, which means now x is going to be positive. X minus something squared, y minus something squared is equal to 1. The distance from the center to a vertex is the A. So there's A. A is 3. So that puts a 9 under there. Oh, and I can also do this. Y, that'd be y minus 0, and y plus 6. Or excuse me, x plus 6. That's what I meant to say. Now they have to give me some sort of information in order to get the other values. Well, I know that the asymptotes are, these are the two asymptotes, and actually the book made, I copied this right out of the book, they made a little mistake. I think that needs to be 12, and that would have to be -12, by the way. I think they got those signs backwards, but we didn't need to use those anyway. All we need is the slope. So it didn't really ruin the problem. I just need this right here. So now from the center, I'm going to use a slope of 2, but I have to work my way over to this point. So up 2 over 1, up 2 over 1, and up 2 over 1. And now I could make the rectangle. 1, 2, 3, 4, 5, 6, here, to here. And I don't have to do this. All I'm telling you is you got to work your way from the center to the corner of the rectangle. Now, how will you know when you reach the corner? When you're even with that right there. You guys see that? Any questions on how I use the slope there? You got to work your way over to the vertex. Then that's the corner. So what I found out is that the distance from here to the helper point, or what I found out B was actually, B is 6. So that puts a 36 under here. And that's how you can use those asymptotes to get the other values. But I do think they mixed up the minus 12 and the plus 12. They got them on the wrong ones. Write an equation for the hyperbola with the given characteristics. How about vertices at 3, 2? 3, 2, and 3, 6. 1, 2, 3, 4, 6. Oh, well now I know that this hyperbola opens up and down, and that tells me that the y is positive. So we usually put the positive one first. So we have this template. We know we have to fill in those 4 numbers. These numbers are small and they're nice integers, so we know the center is right here. 1, 2, 3, 1, 2, 3, 4. So 3, 4. 3, 4, there we go. So keep y with y and x with x. The 4 goes there, and 3 goes there. Don't mix those up. That's a common mistake if you go a little too fast. Now A is distance from center to vertex. So A is 2, and that puts a 4 under here. Now, you gotta know some terminology. The conjugate axis, well, the transverse axis connects those. So this is the transverse axis, and it has a length of 1, 2, 3, 4. The conjugate axis has an overall length of 10. So we go 1, 2, 3, 4, 5 this way, 1, 2, 3, 4, 5 that way, and we could use that again to draw the rectangle. It doesn't say graph it, so we don't have to do that, but the bottom line is this B ends up being 5, so 25. So you end up taking half of the length and squaring it to get that B. Hopefully that's a little more obvious when you draw it out. Any questions? All right. And the last one. Back to parabolas again. I like to have, like I've said, a review of parabolas almost every day so that we don't forget. A painter is throwing a paintbrush to his buddy on a ladder. The painter on the ground throws the brush with, not when, with an initial velocity of 64 feet per second. The brush's distance y in feet above the ground after t seconds can be modeled by that parabolic equation over there. So write the equation in standard form. So y minus 6 is equal to, I'll add for the, I'll set it up to complete the square, equals negative 16 times t squared minus 4t plus blank. So we got the 6 over to the other side and set it up to complete the square. I got to take that negative 16 out, which makes that a minus 4t. So 4 divided by 2 is 2, 2 squared is 4, but I've actually minused 64. Minus 64. So we have y minus 70 is equal to negative 16 times t minus 2 squared. If we write it the way we've been writing these, we would write t minus 2 is equal to negative 1/16 times y minus 70. We've been putting the p with the one that's not the, oh no, is that backwards? No, that's how we've been writing it. Which one's squared here? but I don't get too worked up where the P is. So that's how we probably should write it, because that's how we've been writing it. It doesn't really affect this question. What is the maximum height the brush reaches? Well, we know that T is being squared, so this would open up down, and then this vertex here is 270, which means after 2 seconds, we've reached 70 feet. So this is also called vertex form. So in other words, you find the vertex. So the answer, 70 feet. You don't have to really do anything extra on that next question. It just asks you, do you know which number you should choose? Any questions for Do the Cause? All right.